Okay, 1 and 2 step algebra equations. If you have not watched my pre-algebra videos, you probably need to go through all my pre-algebra videos. At the bare minimum, you need to have watched the simplifying expressions video because you're going to be behind whenever I start going through this fast. So, what is an algebraic equation? So that would be a plain two-step algebraic equation. So you've got an equals and you've got stuff on both sides. That's what makes it an equation. So if it was just an expression, it would look like that, which is what we covered last time. But this isn't an expression, it's an equation. So you'll also have a variable, which this time is an x. We don't use times symbols whenever we're using algebra because times symbol it would get confused with the x. So we don't use times as an x when you're using algebra. You use dots or parentheses. So that's just an example. We're going to start with one-step algebra equations to get you used to it. So there's 5 different one-step algebra equations that you can run into. X plus 3 equals 10. So you have to think of an equation like you think of a balance with weights on both sides. So this equal sign is saying that everything on this side of the equation is equal to everything on this side of the equation. If you do something to one side of the equation and you don't do that to the other side of the equation, it's going to make it unbalanced or unequal. So the first rule that you need to know with algebraic equations is whatever you do to one side, you have to do the exact same thing to the other side. So to solve algebraic equations, you work them backwards. So you do what you would normally do last, you do that first. So if we are doing PEMDAS, the last thing we would usually do is add and subtract. So that's actually the first thing we want to do. We want to get everything moved around that we can get moved around before we start multiplying and dividing. So in algebra, you do the opposite because you're working it backwards. So since this is adding 3 to my x, to get rid of positive 3, I subtract 3 because 3 minus 3 would be 0 and it's going to disappear. But like I said, whatever you do to one side, you have to do the exact same thing to the other side. So your steps are always going to be duplicated, one on one side, one on the other side. So that goes away and we're left with x. You bring the equals down and then you just subtract 10 minus 3 is 7, and that's finished. Once you get down to a letter without a sign and then one number, then you're done. So basically the same equation, except now you're subtracting instead of adding. So common mistake people make here is they subtract 6 from both sides because whenever it's 3, they subtract 3. But remember, you're doing the opposite. So if you subtracted 6, you would end up with negative 12, not 0, which is what a lot of people think. So the opposite of subtraction is addition because you want this to always end up being 0. And if you know your integer rules, any number and its opposite sign is going to end up 0 when you add them together. Copy that step over here. So those go away. You bring down your x, your equals, and then you add these two numbers. That's just x equals 9. Okay, so if you know from expressions, anytime you've got a number right next to a letter, it means multiply. So if you're trying to get rid of this 5, you've got to do the opposite. So since this 5 is being multiplied by this x, the opposite of multiplication is division. And in algebra, we don't use the little division symbol, just like we don't use the x for multiplication. We use the fraction line because a fraction is just an unsolved division problem. So we put 5 on the bottom. That 5 over that 5 is going to turn into 1. And anytime you have a 1 in front of an x, the 1 just disappears. Copy that exact same step to the other side. So those go away. You're just left with x. Bring down your equals. Do your division. And your answer is 6. Your fourth possible problem could look like this. X over 4 equals 3. So this is a division problem. It's saying x is divided by 4. So if you have a division problem, you have to do the opposite, which is multiplication. So we signify multiplication with a dot, and we put a 4 up here. Don't put it on the bottom. You put it on the top because you want the 4 to end up being on the top, because 4 on the top and 4 on the bottom is going to cancel out, and you're going to be left with x. Copy your step to the other side. It doesn't matter that this one's first over here and this one's last over here. You'll still end up with the same answer. Bring down your equals, do your multiplication. Your answer is 12. Your last step is just a combination of those two steps. So if you had a fraction and a variable, now they can write this two different ways. They can write it 2/3 and then the x beside the fraction line, or they can write 2x over 3. I just want you to know that that is the exact same thing as that. The only difference is where the author chooses to put the x, whether he chooses to put it on the top or just put it beside. They're both the same mathematically. And the same thing can happen if you have like 1 over 2x. And this is more common. Whenever they have a 1 at the top, they usually just move the x to the top and then the 1 disappears. You just end up with x over 2. So you'll see that a lot. This you won't see as much, but it is possible. So back to our problem. So 2/3 x equals 6. I'm going to erase this so it looks less complicated. So what's happening is the x is getting multiplied by the 2 and it's getting divided by the 3. So it's kind of like these two, this third one and this fourth one together. So what you do is you multiply by 3 to get rid of that 3, but you also divide by 2 to get rid of that 2. So what you're doing is you're multiplying by what's called the inverse fraction. Inverse just means flipped. So if this is 2/3, this is going to be 3/2. And when you come over here, make sure you don't write 2/3. Make sure you write 3/2. Now, these just cancel out and you're left with x equals. You will have a calculator for these algebraic equations. So if you don't know how to multiply fractions, you can just type it in 6 times. In case you don't know where the fraction key is, it's right here. It's got an n over a d, so it looks like a fraction. You hit that one time. You put a 3 on the top. Use your direction key to get to the bottom of the fraction. Put a 2 on the bottom. You can hit enter right here and it's not going to do anything. But if you needed to type something else, like let's say you're multiplying by another number, you need to push the side button to get out beside the fraction. But either way you enter it, it's going to give you the right answer, 9. So those are your 5 possibilities for one-step algebra problems. So I'm going to write 5 problems, and I want you to pause your video once they're all written down, once you have them all written down, and solve them on your own, and then I'll show you how to solve them. Okay, pause your video and try to work those 5 problems. All right, on the first one, you should have divided because this is a multiplication problem. So x will be 7. On this one, you should have multiplied because this is a division problem. X is 27. On this one, you should have subtracted 8. So x is 3. On this one, you should have added 10. So x is 12. Now on this one, you should have multiplied by 4/3. And I didn't show you earlier. I meant to show you how to do this without a calculator. So what you can do is you can take 24 and you can multiply it by 4, and then you can divide by 3. So instead of punching it in on the calculator, I'm going to show you how to do that by hand. So 24 times 4 is 16, 8, 9. So it's going to be 96. Then you can take 96 and divide by 3. 3 goes into 9 3 times, and it goes into 6 2 times. So your answer is going to be 32. Now that's just for you to practice at home. Like I said on the test, you're going to have this. So it's going to look like this. 24 times fraction 4 down 3. Enter. We got the right answer. Now moving on to two-step problems. Let's take that first one that we wrote. Somebody got it wrote out. 4x plus 3 equals 19. So now you have 2 of those one-step problems combined into one problem. So here you have a multiplication problem, and here you have an addition problem. Always, always, always add or subtract first. So the first thing we want to do is get rid of our 3 by doing the opposite. Copy that step to the other side. Now instead of just an x coming down like normal, we bring down the 4 with the x because we didn't do anything to the 4. The equal sign, subtract here, you get 16. Now we're right back at a one-step algebraic equation. So all you're doing is 2 one-steps in a row. You just have to know which one to do first. So this is a multiplication. We would divide. 16 divided by 4 is 4. X over 6 minus 4 equals 2. So like I just said, first thing you do is add or subtract. So you would add 4 to both sides. Bring down your x over 6, your equals, and add here. Then multiply by 6. Multiply by 6. X equals 36. And if I'm going too fast for you, just pause the video and go at your own pace. I'm just trying to make the video as short as I can. You can always rewatch it if you don't understand it. A lot of times people get algebra the second time they see it instead of the first. So I want you to try to (5x plus 3 equals 38) and x over 7 minus 7, we'll do 8, equals 2. All right, pause your video and try those 2 algebraic equations. Here you should have subtracted 3. Write down 5x equals 38 minus 3 is 35. Then you divide by 5. X is 7. Here you should have added 8. And that multiplied by 7, x is 70. Now, I didn't tell you this, but you can always check your answer when you get to the end. Let's say you didn't have answers and you're on a test. You can take your answer and you can put it back into the problem. So take the 70 and plug it in for the x. So what's 70 divided by 7? It's 10. Subtract 8, you get 2. And over here, 2. So if you get the same answer that's on the other side, then you've done it right. Now I've put all my variables on the left-hand side. Sometimes your variables are going to be on the right-hand side. A lot of people get used to working it this way, and when they see a problem, they switch the sides of the variables. And I'll show you what I mean by that. So this confuses people for some reason. When they get used to doing it the way I've showed them, and then they get this problem, for example, they think that they should start by subtracting 12 just because they've always worked with the left-hand side. You don't always start with the left-hand side. You start with the side that's got the variable on it. I may not have said that at the beginning. So since the x is on the right-hand side, you would start by subtracting your 2. And a lot of times they'll when these are flip-flop, it confuses people. They think they should start by subtracting 5 because it's got a plus in front of it. Just because there's a plus in front of the 5 doesn't mean it's an addition problem, because this right here is a multiplication problem. So let's say you had this on the test. The first thing you would do, like I said, is add or subtract. Since your variable is over here, you want to get rid of your 2, not your 12. You copy it over there under the 12, which gives you 10, and then you bring down your 5x. And then since your x is here, you divide by 5, and then x is 2. Now it doesn't matter that the x is on the right-hand side, the number's on the left. But whenever you go look at your answers, they're going to have it written like this. Or they might even just have 2, like A is 2. So that is the same thing as that. It's an equal sign, so it doesn't matter which one you put on which side. But like I said, some people, when they see this, they get confused. If you want to rewrite this like this, it doesn't matter, as long as you keep your signs right. Now, we haven't gotten into negatives yet. That's the next thing we're going to do. So I put my 5x on this side. Make sure you put your 2 with your 5x. Don't leave it behind. And then I just switch my 12 to that side. If that makes the problem easier for you to work, that's fine by me. Anything that will help you get the problem right is okay, as long as you're not bypassing these steps. A lot of people try to bypass these steps and do it in your head. I realize that some people are quick with math, and you can do some of these easy problems in your head, but this is just 1 and 2 step problems. If you don't get these steps in your mind as a habit, then when we move on to 3 and 4 step problems, you're going to be left in the dust, because you're going to look at it and go, there's no way I can do that in my head. And then you're not going to have any of the steps down. This is just an exercise to get you used to steps. You're not going to have 1-step problems on the GED, and you're probably not going to have 2-step problems on the GED. They're probably going to be at least 3-step problems on the GED. Now, on the tape test, you may see some 1 and 2-step problems. So we're not going to do that because it's going to be the same answer. Now we're going to do a negative. Let's say we had this problem. So again, if you haven't watched my pre-algebra lessons that talk about integers, you need to go back and watch that. Otherwise, nothing I say is going to make any sense. So first thing we do is add or subtract. So do the opposite there. Now, if you know your integer rules that you've watched the video, you know that since they have the same sign, you add them. Just because this says -6 doesn't mean you subtract it. Now, if you get confused with that, remember you always have your calculator. Now, for some reason, I've seen people, when they do this, they go to their calculator and they hit negative, which your negative is down here. So they'll hit -14, and then they'll hit -6. And I don't know why people do that, because you're adding something there that's not over here. You only have 2 minus symbols. In the calculator, you've put 3 minus symbols. So you've added something that's not there. So it should just be negative, and the first number has to be negative. If you put subtract for the first number, what it will do is it will say answer, and what it's doing is it's bringing down this answer that you just did. So it'll do 32, and it'll inject that into the problem before you write your 14. And then if you hit -6, it's going to give you 12, which is the wrong answer because it's using the 32. So you have to use this key, which is your negative key, then enter your 14. Then you have to use your subtraction key. If you use your negative key here, I think it's going to multiply it. Let's see what happens. Oh, it just gives you a syntax error. And then it goes back and says, it's blinking. It says this is where you messed up. So you have to put subtraction. So the first one has to be negative. The second one has to be subtraction. It should be entered exactly like that. Hit enter. So it added them together. And if you know your integer rules, you know that 2 negatives, when you're adding and subtracting, you add them together and keep your sign. So that's -20. Bring down your -4x. And those are, of course, gone. So when you get to this point and you get to either divide or multiply, you have to divide or multiply by the number with the sign. If you just divide by 4, you're either just doing it incorrectly or you're going to get a -x, and we can't have a -x as an answer. So come over here, do that. Now, if you're good with integers, you can do that in your head. If you're not, lean on your calculator. So when you're multiplying and dividing, you can't use the subtraction symbol. You only can use the subtraction symbol when you're adding and subtracting, and only when it's the second number. So you can either enter this as a fraction and put -20 down -4 and then hit enter. It'll give you 5. Or you can just simply put -20 divided by -4, enter, and it'll give you the same answer. Because like I said, a fraction problem is just this unsolved division problem. Okay. I want you to try these. -6x plus 4 equals -20. And x over -3 minus 4 equals 10. Nope, -10. So I want you to pause your video and solve these on your own. Okay, so the first step on this one would have been subtract 4. So if you enter that on your calculator, you should have gotten -24. Bring down your -6x. Last step, divide by -6. X is +4. On this one, you should have added 4. So if you enter this on your calculator, you should have put -10 plus 4, and it would have given you -6. because when they have different signs, you subtract, keep the sign of the larger. So in this step, you should have multiplied by -3. So x is positive 18. Now there's one more that's on this worksheet that I don't often see on the GED, but I'm going to teach it to you just in case, because you might see it on the GED. And it looks like this. So what they've done there is they basically just divided the x by 3 and the 5 by 3 at the same time. So if your entire side, and I mean the whole thing, you can't have like a number out here that like +2 or something. If the whole side has a number on the bottom, the first thing you do is you get rid of that number. And you do it just like the one-step problems. So if you're dividing by 3, the way to get rid of dividing by 3 is multiplying by 3. Now make sure you don't take this 3 and multiply by these two numbers. This 3 is not multiplied by those two. It's just used to cancel that out. But on this side, you do multiply. So over here, you just bring down the x plus 5 and equals, and then multiply. And then on this one, the last step is actually subtraction. So since that's plus 5, we subtract 5. So x is 7. So pause your video. I want you to try this one on your own. This is the last one. So you should have copied the step that I did over here. Multiplied by -2. That cancels that out. Multiply by -2. Bring down your x minus 3. Your equals. So 5 times -2 will give you -10. Then the last step is adding 3. So -10 plus 3, subtract them, keep the sign of the larger, or use your calculator. You should have got -7. I'm going to do 2 quick problems from the packet. So these are all just one-step problems. You should know how to do all these. The answers are on the back, but let's just say we look at this one. So the V is on our right side, so we need to get rid of the 8, not the 26. So since that's a positive 8, even though there's not a plus in front of it, it's still positive. Subtract 8 from both sides. And my paper prints out small. I keep forgetting to change the magnification. You'll have a lot more room on your paper. So 26 minus 8 is, I think that's 16. Yeah, right? Or is it 8? It's 18. My mistake. So bring down your V, and I used X every time. It doesn't matter what letter it is. Positive 8, negative 8 cancel out. 26 minus 8 is 18. This one's 2-step. So here, you would just simply subtract your 4 because they're adding. Subtract 4. Bring down your R over 10, your equals, and your 1. Multiply by 10. Multiply by 10. R is 10. And that one you got all the answers also. I don't think there's anything that's going to be a surprise. I think I covered pretty much everything. I didn't do any with zeros, so let's just look at this one down here real quick. So your n over 3 is here. It's flip-flopped with your number. So we want to get rid of this 5 first. It's a -5, so we add 5 and add 5. So when you come down, bring down your n over 3, and then 0 plus 5 is just going to be 5. So multiply by 3, multiply by 3. N is 15. Okay, that's the end of the video.